Very last lesson of 1060. Here we go. Now, in 8.1, you probably noticed as we were graphing a lot of these functions, a lot of the final graphs looked quite familiar. Like we talked about in the very last example, that the last example looks like an ellipse, or a portion of an ellipse from 1050. Well, that's because a lot of these are are functions you've seen before, like a sideways parabola or an ellipse or a portion of an exponential equation. So what we can do, first thing we're going to do in this lesson, is rewrite a parametric equation from x equation and y equation to just a single equation that uses x's and y's. Now here's how we do this. It's a very specific process. We're going to start by kind of solving this like we would a system of equations from 1050. What we're going to do is take one of the equations, here let's write this down, and solve one of the equations for t. It really doesn't matter which equation you're solving for t, so I would just look at them and figure out which one will be easier to solve for t. So for example, if I look at this x equation and I solve for t, I'm eventually going to have to do the square root, which means I would get plus or minus. That's gross. I don't want to do that. So it looks like it's going to be way easier to solve y for t. So we're going to take this as step one, take my y equation, and I'm going to solve it for t. So there we go. Step two, plug that in for t into the other equation. So basically this is the process of substitution from 1050. So now I'm going to take this equation for t, I'm going to plug it in for t into my second equation, in this case my x equation. So as soon as I hit that t, I'm going to plug in the equation I got for t. Now I'm going to square the top and the bottom of this to get that. And I'm going to make this look a little nicer by doing this. And here's my equation. So I took it from two equations that used one for x, one for y that used t's, to a single equation that is just using my x's and y's. Now the reason I moved things around to write it like this is that hopefully you would recognize this from 1050 as a sideways parabola. The y is squared and this is positive, which means it's a parabola facing this way. And the vertex of the parabola is going to be at -3, -1. That's where this point is. And this is from example 1 in lesson 8.1. So you can go back to example 1 in 8.1 and you'll see that the graph is a sideways parabola with the vertex at this point. Now, one thing you'll notice looking at the graph from 8.1 is we don't want the whole sideways parabola. We only want a portion of it, mainly this portion. I want only the portion for t greater than or equal to -2. So let's write this, but we only want the t greater than or equal to -2 part. So what we're going to do is just take our t value, plug it into one of our equations. I'm going to do y, and I get -5. So if I only want greater than or equal to this point, then I only want greater than or equal to this point. And if you check your graph on example 1 and 8.1, you'll see it's the same thing. I only want the points that are greater than or equal to y value of -5. So it should kind of like look like this. And here's my y value of -5. So that is how we take a parametric equation and then bring it back to its original equation of x's and y's. So what I would like you to do is try example 2. You'll use the same process. Solve one of the equations for t, and then you'll plug that in for t into the other equation. I will give you a hint. It will be easier to solve for t in the x equation, and then plug that into the y equation. So pause the video, try that out on your own, and then come back to check. Let's check your work. Now, you may have gotten a little stuck on this one if you don't remember your logarithm properties from 1050. So remembering that ln and e cancel each other, so that's how I can help solve for t. So when I solve for t, I get that. Then I plug that back in for t. 2 negatives make a positive. Now you can't cancel the e and the ln until they're right next to each other. However, we do have a log property that says this number in front, I can change it to an exponent. So I change that to an exponent, then the e and ln cancel because now they're next to each other. And I get this, square the top and bottom to get x squared over 4, or 1/4 x squared. So this is a parabola. This is an up and down parabola. However, we only want t greater than or equal to 0, as you could see, because this is example 3 from your 8.1 notes. So if you go back to example 3 in 8.1 and look at the graph, you'll see that we only want from the point 2, 1 up to the origin 0, 0. So this time I'm just explaining which portion of the graph I want. You could also say something like, I want from 0 up to 2, and I list, these are the x values. So I want 0 not included up to x equals 2 included. So those are a couple different ways to explain which portion of this parabola I want based on those parametric equations, what t is. One last problem for this video. And this one is actually different than all the others. Anytime you see sines and cosines in it, you're actually going to solve it differently. So in this case, we're not going to solve one for t and then plug that into the other one like we did in the last 2 videos. In this one, we're going to take each equation and solve it for sine or cosine. So what I mean is, for this first one, I'm going to subtract 1, then divide by 3 to solve for cosine. And in the second one, I'm just going to divide both sides by 2 to solve for sine. So anytime you're dealing with equations that have sines and cosines, this is what you're going to do. Get the sine and the cosine by itself. Now here's why. We know that one of the most popular equations that we use in 1060 is this. Sine squared plus cosine squared equals 1. Or in this case, cosine of t squared plus sine of t squared equals 1. So what I'm going to do is take this equation and plug it into the cosine portion. Then I'm going to take this equation, plug it into the sine portion. And now I'm going to simplify this. So I'll square the top and bottom. And here's my equation. And if you remember from 1050, you'll recognize this is an ellipse where the major axis is 3 wide and the minor axis is 2 long, and the ellipse is centered at 1, 0. this is an equation for an ellipse, which if you look at example 5 from 8.1, does match what we had. We had an ellipse. That's what it looked like. So it was centered at 1, 0. And the major axis was 3 long on both sides. The minor axis was 2 long. And then we connected the dots to get our ellipse. Now, same thing as before, I only want a portion of this ellipse. So I am going to describe in words what portion of the ellipse I want. So I only want from, let's see, what was our starting point? 4, 0 to 1, -2. Those were the points that I wanted from. So I only want from this to this. And that helps me describe which portion of the ellipse I want in these equations. So that is the first part of our 8.2 lesson, talking about how to take a parametric equation and work backwards to end up with the original XY equation it came from. In the next video, we're going to talk about how to take an XY equation and come up with a parametric equation. So we're going to go the other direction.